So if you're not sure what to do, you should be starting with 0, 1, 4, 9, getting decimal. So if you rely on this table, because these are perfect squares, it's unfortunate that multiplying by 3 means they're no longer perfect squares. So the square root of 3 times 0 is 0, so that works. Let's go from there, get some decimals out.
You want us to grab this table that we're doing right now?
Yeah. Alright. The square root of 1 times 3 is the square root of 3, which is 2 point. Square root of 4 is 2, so square root of 3 is less than 2. I mean 1 point. It's square root of 1.73. So that's kind of tricky to graph, but you can. And then you do 3 times 4, which is the square root of 12. And then you do 3 times 9, which is the square root of 27. Okay, so I'm going to allow you to make this graph, plot your curve. I'll give you full credit. But I do want to show you, because I know some of you are already thinking of it, what might be better. So this works. This one's a little more advanced. So this is better. We can still start with 0. The square root of 0 works. But then I want to think about, I would really love to have, I'd love to square root 1, I'd love to square root 9, I'd love to square root 4, so I want to create these numbers. So I think, what would I have to multiply 3 by to get a 1? Got me? 1/3. 3 times 1/3 gives me the square root of 1, which is a nice even number instead of a 1.7. What would I have to multiply 3 by to get me a 4? Anybody get this one? So thinking algebraically, we don't know what to multiply by to give us a 4. So it'll be 4/3. So 3 times 4/3 is 12/3. Good job. Which is the square root of 4, which is 2. Because I'm trying to come up with a perfect square factor. So I'm really thinking about how I can best use my numbers. This one's the decimal one. You can just copy this one. Okay, so how would I make 9? 9 over 3. Or just 3, right? 9 over 3 is 3. So 3 times 3 gives you the square root of 9, which gives you a 3. So now you don't have decimals if you set up fractions for x values. Now, that means you might want to change your x-axis of your graph, to see these, or maybe you get little tiny numbers. Those are all things that you guys are kind of developing and learning. What noise? 1/3, 1. Oh, that's, yeah. 4/3 is 1 and 1/3, and that's up at 2, and then 3, 3. So that's where you're at. Gabby, what's your question?
So that graph is there, and you're like all decimals, right?
Yeah.
But when it comes to this, and that's on the Y one, when you do it on the X series, those would be decimals if you
Almost equivalently as uncomfortable, right? But I mean, I don't.
So one I meant to ask, like, would that change the look of our graph because that has the decimals on that side, and then this graph has the fractions on that side?
No, they'll be on the same exact place. Okay. So like I can plot, so 0, 0. So 1 and 1.7, like the first line there, it's gonna be right here.
Oh, okay. It'll follow the same line.
Yeah, 4, 3.4 will be right there. Actually, a very cool question. 9, be 5.2 would be right there. So this table is the blue dots, and this table is the red dots. They make the same line. I'm going to put the parent function in here. Which is 0, 0, 1, 1, 4, 2, and 9, 3. And you can see what effect the 3 has on the graph. Torian, how would you describe the effect the 3 has on the graph? So this black one's the parent function, and the red one's the one with the 3 in it. Okay, so visually it looks like a vertical stretch. Visually, you can also call this a horizontal compression. Stretching something vertically and squishing something horizontally has the same effect. So if you pull up on a rubber band or you squish a rubber band in, the whole thing goes up. So here, since it was the X's that were truly affected, the best description would be a horizontal compression. But for your understanding right now, seeing a vertical stretch or a horizontal compression is really good.
That's like an SAT kind of question. You'll have a graph and it'll tell you what's the best way to name it, and it'll have both of those answers.
No.
That wouldn't be on there.
No. Let me see how this would show up. They'll just say, which graph shows up horizontal translation. Horizontal compression. Or the graph of y equals the square root of x is, vertically stretched by a factor of 3. And that's a 3 in the front. Or horizontal compressed by a factor of 3, and that's a 3 inside. All right, so I was going to go over the answers for the Google Slides thing, but not everybody could turn it in. Let's just look at the workbook, page 82, 2 and 5. You need me to go back? Here, I'm gonna.
Kind of the same.
This is what you asked.
Oh.
Vertical stretch, horizontal compression. Both graphs are taller. You see the difference? Jordan, do you see the difference? This number here is going to make a taller graph, vertical stretch. This number here is going to make a taller graph, what you call a horizontal compression.
But they're the same kind of. Okay.
Alright, so here is number 2. That's what it should look like. That's your domain and range.
The thing that I'm doing for you. Yeah, I know. It is, but like you can't.
Yes, I do. Thank you. Okay, so it's important that you know your progress report grades. So I do want you guys looking at that and asking me questions today. No, they don't come out today, but my grade goes in today. So I want you guys just it's not in yet, but I'm gonna try to get it in. It's not in yet. So before we do test corrections, I want to tell you about an optional project for third quarter. So it's due in 4 weeks, which is way too much time, but an optional project. We'll talk about it right now. This is a research project. So you actually don't have to do math in it, which I think is like good. This is all by yourself. So you research a mathematician and you make a little poster board. So I have some really nice examples I can show you. But what's important about the research, you're quiet, the purpose is to acquaint students with the history of a famous mathematician and discover their contribution to modern mathematics. You should look at the background living conditions, see what interests they had, note the time period and what was happening during that time period. And so this is due in 1 month, which is way too long. So we'll have to continue to remind you of it, but it's due right before the end of third quarter. So it's 100 points. It's like a test grade. So if you do a nice job, you can get like a 100-point test grade. So the first 50 points out of the 100 comes from this outline. You just have to fill out these details about your mathematician. The work cited is really important. Don't skip the work. What cited do you guys use here in the Cambridge program? Do you guys use MLA here? What? Just, yeah, you guys honestly, you can put any website into Google and put MLA, and Google does it for you now. They'll cite it correctly for you. So anyway, the other part is the poster. So make sure you read the rubric. You need to include all the required information. Visually, it shows great effort. Great effort. If it shows some effort, you'll get 40. If it only shows some of the information, you'll get 30. And if you have very little of the information and you lack effort, I'll give you 20 just for doing it. So to get the full 50 points, you have to have your work cited correctly. You'll only get 40 out of 50 on that info if you don't cite it correctly. Okay? So all the info in this has to be on it. So if you go to Schoology and pull this up and it's in there this week, here's some websites that you can use to make it easy for you. No Wikipedia. Okay. There's a nice University of Cambridge one. That'd be good for you guys. Wikipedia. And here's some things to consider, so read through that. And then here's a list of 50. You don't have to pick one of these mathematicians, but I don't want any repeats, so you have to sign up on the back cabinet of who you want to pick. So I actually think the most famous ones can be the most difficult because there's so much information. So don't necessarily pick like Albert Einstein. So you might be like, well, really, I'm gonna go on a limb here and say every scientist uses math. So if there's a scientist that you love more than others, and you want to do a scientist, I don't think it's on here, so you can just write it back there. Okay. So anyways, your poster it doesn't have to be a full poster. You can do a half. You don't need a color printer. Like this one's really nice. Someone had a color printer, but they just use markers. Yeah. Here's a nice one. So what I'm really gonna be looking for is their math. So if you can print their contribution, it'd be really good. And then you're supposed to show where they're from and a time period. Something important that happened during their time period. So this is a really good one. So I don't know what materials you guys have, but you can do it on marker. These all have like papers. No, seriously, this is so nice. I have me black and white photos. You might just like socialize. Once you get a Star Sexo website, you can go to Google and put in MLA, and Google will put it in the right format for you. Does anybody else have any questions? This is totally individual. You guys, every year I get people who come in with a plain white board and black marker. It's not, you won't get credit. So don't wait till the last moment. If you don't have a printer, you have to draw something. Like make it show good effort.
Who's the one girl with glasses? She's like the best.
From Hidden Figures.
Is she
You can pick her. You can pick her. Oh yeah. There's 4 mathematicians, so people usually argue over those. You should watch the movie. You should watch the movie. No, not the. He means the person, not the actor. All right, you guys, get out a red pen, and I will pass out your tests. Highlighter. If you don't have that, get out a separate paper. So there's 2 versions, but other than the graph, the questions are very similar. More people have this graph, I think, in this class.
Oh, you almost busted it. No, I have to go. Are you being serious? I know this competition. It's so long.
I guess so. And then I get my sister.
Yeah, I didn't pass my job. Which is weird. Oh yeah. I didn't see that.
If you had a third degree graph, and if your equation was 2x to the third, those are the numbers that you should have had on your table.
Why would you take off points for that? Like, I got the whole question right. Can you please stop it right now?
I'm not talking to you.
I know you are. I know you are.
Yes, you guys. So in addition to this optional project, please know Khan Academy is still out there. If you didn't get a 60, get on Khan Academy, watch videos, do practice problems, and I will remediate your grade to a 60. Okay? Which if you do every homework in your Khan Academy, there's no reason that you can't get a C in this class. Okay? You just got to come in after school. You guys, I'll give you every opportunity to pass if you just show the effort. Okay? No. So it's a remediation. So want to make sure that you can earn credit for the course if you're motivated to do so. Whether that, you'll go on and you'll do the videos and the topics that came from chapter 5. So it doesn't say chapter 5, it's in my course. Yeah. Go through Schoology, go to Khan Academy. There's 2 videos on factoring cubes. There's practice on taking out GCFs. There's practice on graphing polynomials. Okay. So you have to get a 3 out of 4 on the practice problems for the Khan Academy. Yeah, so it won't turn in focus, your test grade won't turn to a 60, but there's a different Khan Academy column where I will put the points that would average your test grade to a 60. Okay. Any questions on these problems that you can see? So if your polynomial has a 4th degree, you have to wait. I have a different graph for you, but everybody had the same 6, 7, 8, and 9. Almost nobody did 9 completely. Even everybody had the same 6, 7, 8, and 9. What part do you understand? You understand what happened in number 6? The negative 5 and 2. So, like, how do you say that? I think, man, well, that student just needs more practice.
You said it was obviously about the quadratic formula and square root something.
No, I said perfect cubes, which is this one and this one. So no, what I said was it's like the review assignment in the book, and I said in addition to that, you need to know how to cube. You need factor by cubes and the quadratic formula. So that was just in addition to that. So out of these 18 questions, every single one's a little different. There's nothing repetitive here, which is what's so challenging, is you can't just keep practicing the same problem over and over again and have it down. It's like a comprehension more than a repetition. If you are not doing corrections, you can start the assignment.
What is? I forgot the second one on this. That's why.
Which one do you think it is? Go ahead. Which one do you think it is? Oh my goodness. No. No, we're not talking. Everybody has the same 6, 7, and 8 though. Okay. So yeah, this is x to the third.
So I got -2 because I forgot to put square.
Yeah. So I think each one's 6.5. So I give you 4.5.
Yeah, I got -2.
Because it's you mean number 6, right? Because it's a fourth degree polynomial.
Yeah.
You should understand that the factors would be squared in that case. All right, I'm gonna go on, you guys. I can come back to this in a moment. Yeah. The one where this is half. You got to take a 2 out. You could take a 2 out from the start. Step 1, take a 2 out. If you didn't take a 2 out, step 1, this is your answer. From here, you go 4x squared minus 1. From there, you go 2x plus 1, 2x minus 1 for full credit. That would have been full credit. I tell you, almost nobody got that one. There were no hundreds. Maybe it was that problem right there. Usually that problem or number 12. So everybody has the same number 10. So everybody can do number 10 right now. You should have instant at it. This was the result. A lot of people stopped, but you could factor this. Plus 1 and minus 3.
So everyone had the same number 10?
I'm going to say number 10. How many points did I say? Okay, pretty generous. It says find the factors. These are the factors. Did you ever show all 3 of these? You tested them all. How'd you find them? Yeah, this was You got 5.5 out of 6.5.
So why'd everyone get half credit on the number 12? Because I got half credit for that.
Because you're supposed to do, if the leading coefficient is something else, you're supposed to do all of the numbers over that something else.
I did that. Yeah, Matthew did that.
Okay, well, let me check it out. Did you put plus or minus?
Yeah.
Are you sure it's not purple too? Well, you didn't list the ones without the 2.
Oh, yeah, we did do it.
It's the numbers by themselves and the numbers with the 2.
She's getting a little worried there.
We put this on the table on the filter.
He asked me weird stuff like that all the time.
Yeah, let's keep going. Let's keep going. Now, the back is also completely the same. It's just in a different order. The back, the back is all the same questions in a different order.
For real.
Yes, sorry.
Got the question right. Guys, you guys are being kind of loud. No, credit card detail. Equal matter. Equal matter. But I'm saying you don't like. Yeah. What?
What's your seventh period? All right. It doesn't. Here's the rest. Here's these two. These are just in a different order. See? See? Yeah, because of 14. Yes, please.
Yeah, but she said I can do that.
Sorry, guys. Here is the other graph. Sorry we didn't get to it really. It was a U shape. It was an awkward U shape. Non